สวัสดีครับ Hello. Right. So I think you guess where I'm coming from. Right. So yeah, my name is PD. Then I will talking about the our TiDB, which is I think is easier to pronounce. So TiDB, right? Um, right. February 2009, which is 17 years ago, I went to my hometown, which is Thailand, but I'm going to in the middle, which is like Bangkok is on top, and then it's an island, it's very small island called Got Muk, right? Then it's very nice. You can homestay over there, and then you just walk to the shore, and then you just like scuba diving over there, right? It's very nice. You should try. It's not a nice resort. It's just like a home of the people that the fisherman is over there. But yeah, that's not me. I just searching for the internet. But yeah, it's like you can walk on there. Right, it's very beautiful like this. Right, it's just like you're just walking out from the house and then you can see it, right? And it's because it's really small island, so it's not speedboat or the big boat. You need to using the local one. Right, it's a small one. So, but they can bring you into the some islands, and then you can jumping out from the boat and scuba diving. Right, I don't have a tank. I just scuba diving, and you can see that it's very hard. I mean, when you jumping out, it's very fast, easy. But when you jumping in or you climb in, it's very hard. So I have my cameras at that time, the Olympus, this one. So yeah, it can be like waterproof. So it can you go into in the water and then take a photo, videos. I put in my neck like this, right? And then I try to climb up into the boat when I finish. Bad luck that the camera and the cables is just hanging in the boat, the edge of the boat, and then just drop down in the water. So my first thought is, I didn't regret about the camera. What I feel sad is my photo inside that, right? Your memories, right? The camera you can change, right? Your phone as well. You lost your phone, you have Google Photo, you have iCloud. You don't care much about the phone loss, but you care about the memory of yours. Then I think 1 month later, someone found my camera. Yeah, they found my cameras. I'm really lucky that 1 month later, someone found my camera under the sea. It's like 10 meters down there. They're using a tank, they're going down, and then they see something shining with the light. And they thought it's a trash, like a can or something like that, right? So they can try to get the trash and then throw it. But actually, it's my cameras. And they turn it off. And they say, wow, you can turn it off. See that man, which is 17 years ago, still have hair, but now it's not. So then, yeah, they are posting my pictures in the like a web board at that time. That yeah, we found the cameras. This is a photo that we found, and anyone is an owner of cameras. And then my friends call me, hey, your photo in that web board. What are you doing? I say, oh really? So I go into that web board, and then I got my camera back. Right? Even now I keep the camera, but I think it cannot open anymore, but the photo is there. My memory with my current wife on the right. Yes, we still together. So yeah, we have that picture, our memories of 17 years ago. So that's it's important of the memories, right? So what is related with our talk today? So yeah, when we're talking about the AI, I think previous sections, thank you for Edwin, talking about the saving cost, right? And then you burn token, how you save the token. So our TiDB can help in that point, right? You can choose models, and then how we can optimize the cost as well in terms of the tokens. So why is always double? All right, I think they want to go into the fast one. Right, so I think it's a build agent, it's easy, right? You're using core code, codecs, right? You're just giving the context. But it keeping alive in the production is very hard. The reason why is you can using any tools to build the prototype, right? Then you have the prototype, everyone using it, the testing that, right? And I think this is a typical that you are using, right? Using the agents to write code and then using MySQL or Postgres in order to store the data, and then you have vector database and Redis. It's just easy, right? It's just a step to building that. Now, but actually this is the one that you are using, right? You need to like copy data from MySQL, embed it into the vector database, and then you have the API to call. Very messed up, but it's work, right? You have a weekend to pitch your CEO, hey, this is my program, that is work. So yeah, in 2 days, it's work like a genius, right? It can work that, okay, this is our business requirement, and this is a resource. I think you all here is, can we do faster than this? But now, actually the agents is always, my slide is going. Right, so the agent is not a chatbot, right? They will need to be like in the step of working, right? In other sites of fetching the orders, checking the policies, calculate the refunds, and then call API, right? So it's kind of like step that agent need to be done. It's not chatbot that you're asking and then give you the answer, right? The agent is like a flow that you need to work through in terms of the business logic, right? That's the idea of this one. Now, most of the agents running on the pod or memories, right? If that pod is gone, the data, the memory is gone. It's the same that I'm losing my cameras, right? It can be losing. And the most important is not about the agents or the program that you build. It's about the memory or the data that inside that, right? That's the memories. So why its processing is die? It can be OM, out of memories, because the contact is too long, right? That port is too small. Because the prototype is very small, right? You're just doing the small things, but once you go production, the contact, the information is too long. So the port is got killed, right? And then you may have something that you need to update your programs. So you rolling upgrade the port. But the problem is it's rolling deploy. So may hit some port that have something working on, and then it's gone again. Right? So it's many ways that your port can gone, right? That's the normal. Right? So yeah, you might asking to the side, which port died today? Right? You have multiple bots running, and then suddenly it's just queue. You cannot predict which one. It can be queue anyone, right? So that's the happens today. So now when we're talking the pod is gone, yeah, we can restart the process. That's fine, right? It's consume the same thing. But the thing that is wasted is your token, right? Because before that, you see that the agents working the step 1, 2, 3, 4, 5, 6, 7, 8. Maybe in the middle it's gone. And using like a 500 token already. Then it restart. Then you need to restart from the beginning again. So you're wasting a lot of 500 token again, which is, yeah, it's even though it's quite small, but if you think that you have 100 sections multiplied by 500, right? Even though that Alibaba Cloud helping you to save the cost, but still the cost, right? So yeah. Yeah, so rerun is didn't save. And actually, if you facing about the financial thing, right? Let's say in the first run, you're facing information is policy and then calculate and then refund send, right? Let's say the customer had, I don't happy with your services and then I want to refund. Yeah, your agent, okay, in the chat, agent, okay, we will refund to you. Then they start transfer refund and then the pot kill, right? What happened? Yeah, it's restart by himself. But the problem is they will repay and refund again. I like it. If anyone doing this way, I will subscribe your service. I will get you 2 refunds. But yeah, that's the problem, right? Yeah, we spent 20 years figuring out how to do the payment, and then now your agents keep credit card, keep in your Python. That's quite risky. right? And then, yeah, this is the typical that you have, right? Your agents logging in and then query from the traditional databases. Yeah, it's order, it needs to be refund, yeah, checkbox, right? And then you need to talking to the embedding data, right? For the vectors, filing is what is the policy of the that transactions. And then you have radius in terms of the memory conversations. Yeah, that's none of them it's the same things, right? You need to have like data replicating in each other. So sometimes the data is lacking between the MySQL and vector database. So let's say today, yeah, we refund for services 2. Yeah, services 2. Then the business coming, hey, service 2, we stop refund. We refund only service 3. Right? That means you update the data in MySQL. But you need to have time in order to embedding the data before putting in the vector database. And then at that time, if the customer coming in and then refund the service number 2, they can get the money. Because the data that you update from the policy is on MySQL, but not in the vector database yet. That's the lacking in between, right? So that's kind of the problem that we see in the real productions. We didn't see this one in the pilot, right? It's very small, it's just a functional test. It's not there, but this is one that we found in the productions, right? So the agent is kind of like a transactional. It's not like a chatbot, right? So that it's kind of like LM is a brain, right? Human is a brain, and then database as a TiDB is a neural system to connect all of this. That's the idea. Now, what we are doing here is we adding our TiDB as a checkpoint. Right? Every step, they will have a checkpoint. So let's say we have a step. Right? Every step, we will have a checkpoint and saving checkpoint into the database itself. Right? So for our TiDB, we're helping that on the ASICs. Yeah, autonomy, consistency, something that makes sure that the data is keeping every checkpoint. So which step that you are in. And because of our TiDB, you can scale to the zeros, which is if you want to save the cost and you don't have any workload, you can scale to zeros. And the thing is, we're using just a plain SQL, like select, insert, update, delete. It's normal SQL. Right, so that we believe that we can eliminate that one into this one. Because our TiDB cloud, which is running on Alibaba cloud, that we can do the orders, the agents, and the vector embedded in the same database. We can do both normal database and agents, which is the vector database inside the TiDB. Now, let's see in the actions. So I just using the wipe code to building this. So basically we have the keyword and resume, right? So this one I'm using Pythons, and there will be the activity agents. And the first one we're running on the memories, which is didn't use our TiDB yet. So yeah, the agents running in and then start the draft the outline using around 140 tokens. And the second one coming in, the third step coming in, the fourth one, zoom in. Right, and then just queue. Right, so what happened? Now we're doing the step 1 to 6, right? And everything is just queue, right? But you spend the token around 1,000 already. So what next? Yeah, we need to restart, right? And then because they don't have a checkpoint, they need to start from the beginning again, right? So they need to restart from the beginning again and consume your token again. Yeah, when the people looking at the screen, they will feel really slow. And the people doing the live demo will be nervous that it's going to running or not. Right, yeah, so it's finished. So actually the total of spending is around 2,300 almost 2040, and US just 1,000 already, right? Because it's restart in the middle of the processing. Now let's see in the TiDB. So this is on TiDB, same idea, just running. On the right hand side, we query from the real database. I will be showing the console of the database later. But the thing is, yeah, when the first one is finished, we writing down into the database which step we are, right? And also the detail if you have it. But yeah, that's the idea that every step we have a checkpoint, which is running, saving in the database, which is TiDB. The consume of the token from the beginning is the same, right? Because it's the same program. Let's waiting in to 6, the same things, and then we queue. All right, now we queue, right? It's consumed around 1,000 the same, right? Because the 6 step should be the same, right? Now, but in the database itself, we have the record which step they are in. Now, after the pod restart, the agents will talk to the database which state that I am in, then retrieve all the information and continue from the one that they are stopped. That's the idea, right? So one is finished. You can see that the total is only 13, right? 1,300 compared with the previous one, which is you didn't have it. It's around 2,000 something, right? It is different 1,000. So in this case, meaning that you save money, right? You're using Ali Cloud, you save money the first time, and this is the second one that you can save the money, right? That's the idea of that, what we can help, right? So you can put our TiDB as the agent's memories, right? That's the ideas. Now, so yeah, so what you just watch is we have the agents, right? We have the S step. And then in the between, we just queue that pod, which is we talking about which pod we die today, right? Any agent can die, any agent can restart. So that's what happens. And then, yeah, because we have the insert step into the TiDB, and then one is restart, the agent will read the checkpoint and skip the pay work already. Yeah, I just capture the screen in case that the live demo is not work. So hope you're doing the same thing when you're doing the pilot, right? That save the screen to pitch the vendors. Right. So yeah, that's the idea that if you're not using TiDB. So yes, this is just a resume logics, right? You just select step number, step name, token use, and update from the table checkpoint where the task ID is, right? Just a normal way to checking the checkpoint that we are sitting in the database itself. So you can see that it's just a normal database that you can use before. You can like Oracle, Postgres, MySQL, MariaDB, it's the same idea. Right. So yeah, that's resume, and then we just using the token that not wasted because it's not to restart everything. Right, so that's the idea how we can do it, right? You can use in our TiDB when the use case. This is I think it's just a sample of our TiDB customers, right? Minus, you might know about Minus, Kimi, and also Define and Plot. All of them using our TiDB, which is the big picture is every agent have their own database, which is TiDB. So imagine that I'm logging into Minus or Kimi, and then I'm asking something like, what should I have Korean food for today? Right, just as normal. Then that main agent pick up my contacts, and then they will spin up the sub agents to fighting for the soup, for the noodle, for the BBQ. That each agent have their own database, right? And then they researching And then once they get the data coming back, then they send the data to the main agents. So that's only one migration, only one my project. So at least we have at least 4 database, right? But you don't have only one customer. That's for the pilot. 4 agents, that's fine. 4 database, that's fine. But if you have 100,000 users, and each user have just only 10 projects, you multiply by agents, 10 projects, and then each project have 10 agents. So now, in minus, they have a 2 million agents, 2 million database with TiDB. Not just only the number of the database. You think about how the fast can be spin, right? I think you ever try to set up MySQL or Postgres in your laptop. It takes a minute. It's not like a second, right? And if you're waiting the customer to coming in and asking you a question, what should I have for the dinners? And then you wait the agent to create a database in 2 minutes, your customer is gone. That's how we did it. We spin the database in a second. That's the ideas, right? Right. So, and you can try on today. We have open source, which is the first one is mem9, mem9.ai on the right, on the left down corner. This one is memory for agents. You can using OpenClaw, Hermes to connect to this mem9 and using as memories. And behind is TiDB. But we use MCP to talk to your agents. So you don't need to create a database. You don't need to create the tables. You just call MCP to the mem9. The right hand side is the write 9 is a persistent file or directory for keeping the files, like your PDF or JSON files, also using MCP, right? So these two we provide to the open source, and underlying is our TiDB. So it's all MCP. Right, then I think this question I can ask before you even ask me in the end. Can I do this with Postgres? Yes, you can do it in any database that you use as the checkpoint, right? Why TiDB, right? Because Postgres, MySQL, SQLite can do also insert, just insert. Anyone can do. So actually it's different. It is. The normal database like Postgres, they will have the primary for the writers, right? If that's the pilot, that's fine. But once you have the customer, the real customer, like 100,000 users, 1 million users, the write primary cannot handle, right? Even though you have the replica for read, but that one is just for read, right? It's a checkpoint that agent can read, but the problem is it cannot write. So it will be bottlenecks on the master write. But our architectures, we have split into a multiple node, which is each node can be the writers. So once the data coming in, they can using any node to writing the data, and any node can reading the data. And we also just can add the node online without require you restart your applications. It just works. That's one of the difference that we have multiple write and multiple reads. So for the beginning of the pilot, it's very fine for the single database. But once you scale, when you have the real customers, now this one is the difference. Not just only that, it's about the queuing as well. Because if your primary is die on the Postgres, right, your app, your agent is stopped until the read replica promote as a masters. So it takes at least 30 seconds or 1 minute in order to restart the read replica to be promoted as a primaries. But in our TiDB, we use graph consensus protocol to replicate the data for every node. So we have at least 3 nodes. Even though one node fell, the data is still there. So you can connect the data using the data very fine. That we are designed for HA, right? Because we believe that hardware always fails, right? You have a phone, you change a phone every year. but you want your photos there, meaning the software is there. So we believe that hardware always fails. How we're protecting that, that's the software. Right, so we simplify the tech stack. Like the first one, you have Postgres, PG vectors, and then ETL to Elasticsearch for the full text search. And then you need to do some warehouse over there. But all the things, you just simplify using our TiDB. We can do transaction checkpoint. In TiDB, we can have the vector search and also the full text search. And we have a columnar engines, which is like for more analytics data. So everything just a simple one in the TiDB. The sound is good to be true, but yeah, if after this, we can talk later in the detail, but yeah, this is the real one. Right, that's my section for today that I want to share. So keep your photo in the cloud for sure. And then for QR code, we giving free trial for the TiDB. You can try and create a database today, and then using that as the your long-term memory and short-term memory for your databases. I mean agents. All right.
Perfect.
Yep.
Thank you so much. Do you have questions?
My question is from your start of the speech. You say when moving AI agents from demo to production, what is the first infrastructure problem which tends to appear in the first place, which developers didn't design for?
Yes, I think when the pilot is work on your laptop, right? Everyone start from your laptop. Then once you deploy in productions, everything works fine until you hit a certain limit, which is a concurrence. When you have the real customer, let's say you're testing for 10 developers, that's fine, working well. Once you open to open world, then let's say just only 1,000 people logging in. Then the pod will start to crash and restart first. Then after you scale out the pod, the database will be another bottleneck. Then the database needs to be restarted in order to adding more CPU memories. So that is the step that happens. Actually, the real story is minus, right? It's like Kimi. They are starting like, I think in mid of that last year, the pilot is working fine. But suddenly when the hit, when they were popular, the people always try doing it. So it's keeping restart and they cannot scale. They need to stop the user coming in by saying that it needs to be invite only. So you invite list and then invite only. There are some news that there are lead sales in eBay around 700 US dollar for just have the invite. So that's the problem they are facing because they're using MySQL and they have only one master, right? So that's a problem. Then they might get to TiDB in 2 weeks and then they just go off for no invite, it's just going file off. Yeah, so I think the first, answer your question, the pod, the first one, I mean the apps, the agents, and then database.
Thank you very much.
Thank you.
Do we have, yeah.
You can ask me in Thai, if you can.
Thank you for introducing TiDB. I have a question is DB store checkpoint, or more and more store will become the full DB, I think. So how to manage it, is storage DB or cost something else?
Right. The question is if we keeping at the checkpoint,
Yeah.
right, and then it will be adding up.
Yeah.
Right. So in our TiDB, we do like this. When your data coming into TiDB, we split into the small chunk, and that small chunk will be distributed into multiple nodes. Beginning, we have only 3 nodes, but you can adding more nodes, right? 100 nodes as well, and then the cost. When you're hitting the data the first time, they will hitting to the SSD or NVMe, the fastest disk. and then we can have the object storage. So when the data is cold, I mean longer time, maybe more 1 year, the data will be tearing into the object storage, right? This is we using the Ali Cloud.
Yeah.
So running tear down on the storage, I mean, which is lower cost for the object storage. But the thing is, in your agents, you don't need to change anything because we do inside our TiDB.
Yeah.
What you need to do in terms of the admin is define which table or which partition you want to tear down to the chip storage.
Thank you so much.
Thank you.
Do we have more questions? Yeah. You? Yeah. Or you can pass.
Yeah. Okay. Hello.
Yeah.
So thank you for the presentation. My question is like for TiDB database, is there like some configuration, for example, which embedding model or like some modification, or is it like a solution as it is and customer use it, just maybe define only the table and that's it?
Right. As of now, we are only vector tables. We don't have the embedding inside our TiDB, but we have some indications. So normally you need to like put the data and send to the some models and then writing the vector 0, 1, 0, 2, blah, blah, blah in TiDB. So we have some, we open for the, let's say this statement, and then you pointing to the models that you want to use, then we will call MCP to that model and embedding and then come back to the TiDB. Yeah. So we have a sample document to doing that way. Yeah. Thank you so much.
Thank you for the talk. I have two questions. And first, as you mentioned, the reading is faster than normal RDB because there are so many replications. So, and to reach the consistency, as far as I remember, the raft is used. So the consensus, as far as I know, consensus is slow. So which means reading is faster, but writing could be slower than normal RDB. This is the first question. And second one is consensus may occur inconsistency. So yeah, it becomes eventually consistent. But so I was wondering that if inconsistency can occur.
Okay, thank you so much. I think the first question is about how we read and write and why we faster than others. The first one, we're not perfect. Okay, so when you're reading the data, you can connect to the storage engines that coming back. That's also fine. But if you compare with the Postgres, maybe, yeah, this part, I can say that only one, if you are small one, like Pilot, or really small one, Postgres or MySQL always faster than TiDB. Okay? Always. Because it's just a simple stack, right? You just only want the same port, same VM, right? In memory and go back. But for us, we need to talk to multiple nodes. But let's say you have 100 users, Postgres is win. But once you're hitting 1,000 users, now the Postgres will be bottleneck because you only have one node. So there was a certain level that if you are small, the Pilot, that's working fine. But once you're hitting the customer or hitting wall, then that's Postgres, we cannot do anything at all. And what we are TiDB, what we can say that, let's say read is 2 milliseconds, right, for one statement. Postgres maybe only 1 millisecond, right? It's a half. But once you have like 1,000 users, the Postgres will be like 200 milliseconds, 300 milliseconds. TiDB, when you scale the node, is always 2 milliseconds, linear. So that's the point that we are not the super fast, right? But if we're talking about the scale, we are better.
Okay.
The second question is about the consistencies, right? You might heard about the distributed database. They will call eventually consistency, right? What does it mean that, let's say I take a photo now, post Instagram in my phone, but when I log into my laptop, my photo is not there yet, right? And then suddenly, some 1 or 2 seconds, the photo is there. That's called eventually consistency, because they submit in the phone, in the one database, and then acknowledge back. But in the meanwhile, they send the data to the laptop. That's something similar like that. In our TiDB, we're using graph protocol consensus. What does it mean is, we will have with 3 nodes. So let's say I got the data coming into my node, right? Let's say I am the node 1, and this gentleman is the node 2, and this gentleman is node 3. So when I get the data, I not acknowledge to the application certainly. I need to replicate, send to both of gentlemen. Anyone can go back first. Then mean I have to copy or majority of the data. Then I return back to the application. I got your data. Even though in that seconds, I'm dying. This gentleman still have the data, so that can serve the data. Yes, for the write, it might be introduce the latencies. But it again, if really very small concurrent, that's one is faster for sure. But when you have a lot of concurrents, 1,000, 10,000, that cannot catch up. That's why TiDB multiple node help.
Thank you.
Thank you. 감사합니다.
Thank you. Do we have more questions? Yeah. Oh,
yeah.
that's a long run. Okay.
Thank you for your speech. You previously mentioned that TiDB is good for transactional and for analytical loads. So what architectural decisions allows for TiDB to be both good at OLTP and OLAP loads? Yeah.
Right. I was a banker before. Let me explain in the situations. So normally when we're doing transaction in the banking, right, even credit card swipe, that's online transaction, right? You need to fast, and then end of the day, then we need to do the settlement, right? Collect all the debt, and then what is your, so that is analytics data,
Yes.
right? And then there will be some BI, which is a business logic that looking at the customer profile, what should the product we should offering, right? But that one is not the real time. So what typical of the business doing, they have the Oracle for the online database,
Yeah.
doing settlement in the evening, and then they need to do ETL or export transfer to other database, which is the data warehouse, right? And that part, you can do analytics, which is like, what is the total of money they use today? What is the total average of transaction for today? That is on the analytics database, OLAP. Now, because that OLAP is the data of tonight, right? Meaning that the report, it will be on the morning, right? Then CFO coming in, read that report to make decisions. But that data is yesterday data.
Okay.
Am I correct?
Yeah, but I know that for OLTP, for example, Postgres or MySQL is good for LTP loads, and ClickHouse is good for analytical.
Analytics, yes.
Yeah. Does it mean? And I know that for transactional, you use some kind of row-oriented databases.
Yep.
And for analytics, you use
Columnar, yeah.
Yes. Does it mean that you use both in your databases?
Yeah, so the ETL, right? When we going that morning reporting,
Yeah.
actually in TiDB, everything is the same. We have the engines of row store, here the transaction, and we have another engine, which is like a multiple services inside that. We have the columnar engine as well. And the idea is when you when you select the data, you don't need to choose. The engine is smart enough that, oh, this is a row store, then going to the TiKV. If it's columnar store, it's going to the TiFast and get the data fast. So no more ETL. Yeah, so basically we have like row store and then columnar store in the same database. That's what we do.
So it looks like the space is doubled, maybe for
Right. So yeah, the question is, if the first database is 1 terabyte,
Yeah.
a columnar normally it should be 1 terabyte, right? But let's say the table of the address, did you do summary? No, right? The address is no. The phone number, you don't do summary. So for us, let's say 1 terabyte is 100 tables. but the table that you want to do analytics, only 10 tables. Then
okay.
we just choose a table, that 10 table, maybe only 200 GB.
Oh, okay.
So not 2 terabyte, it will be 1 terabyte for the full data, and just 10 table, 200 GB.
Oh, okay. So it's configurable.
Yes,
Yep.
correct.
Thank you very much.
Thank you so much.
We have time for one last question. Do we have one last question? 1, 2, 3. All right. Thank you so much.
Thank you.